Hi everyone, so in this video I'm gonna try to make a string data type in C. It actually is gonna be just a small library. Not for any kind of real applications, but rather for kind of just education, I guess. And actually, when I first started to get into C, I've realized that of the languages that I've used before, those languages either had string as a built-in data type or as a part of standard library, and C doesn't have that. It has string.h, which basically contains functions for working with char pointers or char arrays, and I felt kind of helpless, and as time went on I was able to kind of learn how to work with char pointers and but in the beginning I felt kind of miserable because I thought I was a cool programmer, but I couldn't even do anything without string as standard data type. So in this video I'm going to build kind of a string data type and some functions that are implemented in string.h. It's just beneficial to have some kind of basic understanding of how at least standard tools you're using work. I'm not gonna use Visual Studio because Visual Studio has a C++ compiler, right? And we wanna do this in just straight up C. So I'm gonna use as a text editor Visual Studio Code, and as compiler I'm gonna use GCC. So yeah, let's get into it. So first I wanna create src folder, and actually I wanna create a build.bat file. Build.bat is gonna be it's basically a Windows script, or you can use .sh in Unix like, and basically we're just gonna write out compiler commands here so that we don't have to type them out each time. We're just gonna put them all into one file and just run this script. First I'm gonna check if not exist obj, then make dir obj. If not exist, make dir obj. So obj is gonna be a folder where intermediates are gonna be stored after compilation, and if not exist bin, then make dir bin. So bin is gonna be a folder where our .exe is gonna be located, where we're gonna put it, and basically this code checks if those folders exist, and if they don't, you create them, and then gcc c for compile src, and I'm gonna compile. Let me create the actual files. They're gonna be in this project. One of the most difficult problems in programming is actually coming up with a name, but since I'm gonna implement this library not for real kind of use or application, I'm just gonna use a generic name, my string.h, and we're actually gonna create a separate translation unit for our library. So we're also gonna create my string.c. So it's not gonna be a header only library. And also for to test out our strings, our library, I'm gonna have main.c. And yeah, so basically a separate translation unit in C and C++ is basically, it's just .c file, source file, and every header that is included in that source file. So back to the script. So we first want to compile src my string.c. We're gonna output it to object, and object mystr.o read yum, and we're gonna do the same for main, and we're gonna take those object mystring.o and object main.o, and we're gonna make a program bin. Let's call it just program. Yeah, and also let's do echo off, so that those three commands and will not be printed each time we run the script. It's gonna print errors though, the compiler errors, if we have any, more like when we have any. And first let's test out the script. So my string dot h, and so we can just say main and just test my string, and in my string we should include header guards or include guards. There is a problem when you can include two header files. So for example, if I say here include stdio.h, and then here I'm gonna have also std.h, and then include this, then it's gonna be a problem. Here, and if so, here are the include guards. Yeah, let's define the function void test my string, and in .c file let's include my string h and define this function, and actually in .h we're gonna include standard io.h, and here we're gonna print f testing the script hello from my string library. So let's test build. Oh, so we get warning, but it actually worked, and it created those directories for us, object, and may know everything is great. And it gave us warning because I did not specify a return type. Yeah, so let's run this bin program. Yeah, so it works. This script works fine. Now let's actually return 0, and now let's get into the implementation. Type def struct and string. The reason why we have to use type def is because in C++, if you declare struct, for example, I don't know, object or something, you can create variables with its struct like this, but in C you have to always do it like that. Not to, but I don't want to do that, so we're gonna use type def string, and it's gonna have char memory, or we can call it whatever. I called it memory. I could call it also like data or something. And unsigned int length. Okay, so length is gonna be the length of the string that we have kind of in memory. In here, it's not gonna include null terminator. Basically, the way that strings work in C, it's like a protocol, right? At the end, you have null terminator. So if you, and let's print it out. Yes, and no, just s string. And let's check this out. Print f. So you see, it just printed hello because we have null terminator. So basically it's just like the end of string. And actually it automatically, so after this, here it puts also null terminator, so it knows that, hey, it's the end. We don't have to do that manually like that. But yes, it's pretty important stuff. So we're gonna use stdlib for, we're not gonna use string.h because we're kind of implementing some of the functions that are in string.h. Basically, this project is just to gain basic understanding into how strings work, how string.h works, not to feel so helpless, right? But you should use string.h, and probably you shouldn't create a string library for any kind of, if you want real application for that, because it's probably gonna be worse than the standard one. And if it's not, then you probably know a lot about programming. If you want to make to create a better library, it takes a lot of skill. We're going to use stdlib for memory allocation, dynamic memory allocation, and include assert, just an easy way out. We're gonna assert that the memory allocation was successful with assert. I'm gonna kind of have object-oriented programming in mind. Of course, C doesn't provide any kind of mechanism. It does, but it doesn't provide mechanisms for convenient, you know, object-oriented programming in C. But we're gonna have some kind of mental model. So first, let's define an the most probably important function right now, which is put, and we're gonna define put raw, which is gonna take string. So basically all those functions, library functions, are gonna take first the string pointer. So that's what I mean by kind of saying that we're gonna do it kind of in object-oriented way. And const char. And put row, it means we put row kind of const char, and here put string, and we're gonna put a, in this string we're gonna put this string. Also, it's a since C doesn't have namespaces, it's a good thing kind of to use some kind of prefix as a name for your library. For example, our library's name is myString, so it would be good to do something like that, myString put raw. C doesn't have namespaces. Somebody can, in other library that the user is gonna use, somebody can define put raw function with the same name, and it's gonna be a problem, because I mean, what function do we mean? So we put prefix to have kind of a unique function name. Let's also add a bunch of other functions. Concat, which is gonna return a new string. Concat means like concatenate two strings together, and we get as a result a kind of concatenated string. So here are the rest of these functions that I came up with. So myString destroy, we're gonna require a user to destroy a string, because we don't have destructors. Call this function when they're done using string variable, so that it frees memory that we might have allocated for the string. So myString returns int, because C doesn't have boolean. So yeah, we're gonna return 0 if strings are not the same, do not have the same content, and if they do equal to each other, then we're gonna return 1. Sub is we're gonna take a string and we're gonna extract a part, but we're not gonna modify the string is the original string, but we're gonna have a new string and we're gonna specify from what index we wanna start and for what length we wanna. So for example, if we have string hello world, and we call this function string1, we call this function, we're gonna say string 1, 0 and 5. So it's gonna start at the 0th, the index 0, and for 5, for the length 5, 1, 2, 3, 4, 5, it's gonna create a new string that's gonna contain hello, returns string that gonna have hello in it. And add string is basically just like access to the memory, to the array. Put add is just put at this index of memory array something, a char. And append Basically it's gonna append a string to this string, so it's gonna modify the first string, and yeah. Put allocates memory and puts basically data into string. Let's actually copy all of this and paste it in here. Also, I'm gonna have static void allocate memory and static void memory. Static, actually in C there are three meanings to static keyword. So the first meaning is like a global variable that's gonna be initialized to the 0 value of the type. Then it's like a local global variable. So like in the function, local global variable, a kind of, it has a global state that is shared between, like basically it's a global variable that is only accessible in some kind of, in a function, in a particular function. And static function means that the function is local or only accessible in this translation unit. So we cannot call these functions static functions from main, say, or any other. Like we include, but they're not going to be accessible. It's kind of like kind of encapsulation, sort of. This function dynamically allocates memory for an array. The size of array is gonna be length plus 1 for that null terminator, and array of size char, and it returns pointer to the memory block that's to the beginning of the memory block that was allocated. Yeah, on failure it returns null pointers. So if everything was successful, we're gonna assign length to our string object, and let's just assert. So we're using assert.h string memory. So if memory is null, then we're just gonna crash the program. That's an easy way out. And also static unsigned int count length. Just gonna return the length of a string. I feel like I'm rushing too much. So int l. We're gonna use an interesting syntax for loop L. So in for loop, this is initialization, then condition, and then action for each iteration. It looks like that. And here also commands for each iteration, right? So here we're not gonna have this. We're just gonna place semicolon, and in initialization we're gonna initialize L to 0, and then we're gonna check, and then we're gonna check if value at the position, at L position, if it equals to null terminator. If it doesn't, then we're gonna increment L, and if it does, we're just gonna the for loop is gonna stop and return L. So that's kind of looks good. We're not gonna count null terminator as well. Oh, let's implement put function. First string. What if we should also memory equals 0 here, and if memory doesn't equal 0 here, we're gonna first free location free free okay. String. Yeah, so here if memory is not null pointer, it can be actually empty, right? But not null pointer. But anyway, still, if we've previously allocated something for the memory, then we're gonna free it. And also we're gonna require user, when they create an object, a string object, we're gonna require them to initialize every value to 0 by doing this string s1 equals, for example, like this. That means that every variable is going to be initialized to the 0 value. So if we've already allocated something, then we're going to free it. And length is going to be 0, of course. Allocate memory string, no, just string, and length, and assuming, so if assert is true, then we've successfully allocated something. So we're gonna put I equals 0, I is less than length, let's call it value length, value length I plus plus, and basically put whatever's in the value into the string, and at the end value length. So we've allocated length plus 1 for that null terminator. And I think this is it. Now let's test put string s, and we initialized the values to 0. We actually cannot do this here in C, so we've got to require user to do that, and my string put raw as hello world, and let's printf. Let's actually create a debug function void debug. Let's just debug string, and it's gonna take string and it's gonna just printf as let's test this. Oh yeah. Free memory? What do you mean? Free memory at 3. Oh yeah. Of course. Since we're using free memory in allocate memory function, let's define it before the function, and put raw. Oh, let's now define put raw and put string. We're gonna use put and string value, and string and value, and count length of value. So value length, I'm gonna get value length, and basically we do almost the same here, or let's call this destination and this source. So destination, put into destination source memory and source length, and here I've defined debug string function that just prints string. Let's actually add d in here, and let's also add another d, which is going to be string memory, and so the address of memory, then memory and length. And here user has to initialize every value to 0, since we cannot do this in here, right? Because it's in C you can. And then we put raw string hello world, and let's debug this. Okay, so it seems to be working. 15, let's so 5, 6, 11, 12, 13, 14, 15. Yeah, it does work. Put the wrong string in there, so they should have the same data but different addresses, and they do have different addresses. Thank God. I was kind of surprised to see this. Concat is gonna be also static, and it's going to return a string object. Concat, pretty much the same stuff. String concat result. So concat result, and I'm gonna have string length plus, so it's gonna contain both string and value. Length and so result I until string memory, and then another for loop to put value in value length, and I plus string length, and value, and concat result, value length, string length plus value length. So, oh, and return concat string. So basically we create an empty object, we allocate memory for it with length of string and value length, right? With the size capable of storing string and value, and we fill the data with string and then with value, and at the end we put null terminator and we return concat string. And let's implement the interface functions. They're basically gonna be the same as these ones. So string and value, and basically gonna be the same concat, but string 1 and string 2 and string 2. So string 1 and string 2, and I think this is it. So let's put in here, let's actually put hello like that, hello, and in here yeah, in here let's just put world, and let's have string sc for concat, and sc, oh no, and sc is gonna equal to my string concat string s sc, and let's print out sc something concat result memory. Oh. Here we want to use dot, of course, dot, because it's not a pointer, it's legit thing. Oh yes. doesn't concat all salt, sorry. Of course, sorry. It's not debug. Oh, yeah. So you got so we've got hello, then world, and we concatenated it, and we get sc hello world. So concat works. Let me actually implement the rest of these functions, and then I'll just kind of tell you line by line, because as you can see, working with raw pointers requires a lot of focus, and it requires a lot of kind of mental effort, and that's the reason why people say that, oh, you shouldn't use raw pointers like C style pointers and stuff. Like, yeah, because it makes sense, because it's really easy to have bug in the code, really easy. Append takes as an argument string that we want to append to, and then it appends whatever we want, whatever value we want. Here interface functions and the static function. Actually, let's put it to the rest with the static functions. Basically, we create a temporary variable. We can concatenate two values, our string original and the value that we want to append, and then so basically we don't want to, in append we don't want to return a new object, we want to just modify our old object. So we first get an old data from the string, then we switch, then we set pointer to the new data, and then update length, obviously, and then we free the old data. Actually, it cannot free the old data as a string pointer. Let's just call free. Yeah. Let's test this as well. So string s1, let's do string s2 as well, and we my string put row into s1 we put hello, and to put this, and then we have so we append raw, we append string, and to the first one we append space and an exclamation mark, and then we try the str function s2. So what we will get, what we wanna get is this string printed out. No, let's actually do exclamation mark then space, right? Space. We wanna get this S1. We've got something running here. Pen draw 78. Parameter name omitted. Oh, I forgot to add into append the parameter names value. You see, like, it's pretty bad. Okay, so yeah, it works. 9, 5, 6, 7, 8, 9. So yeah, append works. So let's implement these ones now. They shouldn't be difficult to implement. Index and C and index L, index and string. So here we're gonna return we're not gonna check if memory was allocated, or should we? Well, we haven't checked in here because it's like the user has to deal with all that stuff. So we're just gonna return this. And if the string is memory is empty and we cannot actually do this, well, it's the user's problem. Return, yeah, and here we string, or yeah, like yeah, just not gonna check if memory is null or anything, or accessible. String memory at index equals to C. Let's try this out. My string at printf. Let's printf and C and at, we wanna get at 1, so S1 at 1, and oh, no, yeah, and let's also put at S2, let's put my string, put raw, put at string, oh yeah, put at string, put at string S2 at the index, index 0, we're gonna put X, and at index 1 we're gonna put D. Let's test this. Oh no. Add add string, add string, add string. Yeah, it works. Now let's implement the sub. So we create string sub result and basically so index and length, right? And let's check if index plus length is actually more than string length, right? Let me see. Hello world. So if you say you want to start with the 2 and for 5, 1 2 3 4 5, but if you want to start at 6 for 5, 6 plus 5 is 11, and the length of this whole string is 11. Yeah. So this we cannot perform return sub result. This is not valid, right? Because we go out of boundaries of string, and if you don't, then, well, not exactly length, and the value is going to be memory plus index, and here length. So basically similar to put. I don't actually know if this is gonna work. The fastest way is to just check it, test it. String, let's, yeah, string subs equals so S1 is pretty big. S1, let's get my string sub S1 at 5 4 5, say. Okay, to memory, what did I miss? Missed something. Oh, yeah, it's a pointer. Oh, and let's debug it, right? Subs. No. Oh, yeah, of course. Yeah, that's good. We cannot do that. So let's actually take 3 and 1 2 3 4 5 5. Let's do, no, let's do 6 first. Oh my god. totally wrong here. Here. So we should get LOES and for 5. Yeah, so that works. Now let's implement also equals. If string 1 length equals to string 2 length, because if it doesn't, they obviously are not the same, so return 0. If they are, then for int I equals 0, I is less than string 1 or string 2 length plus plus, and actually let's add it here, and plus 1 string. No, let's not add it here. So if string 1 doesn't add I, and doesn't equal string 2, we're gonna return 0. And after that array, if everything equals, then return 1. And so printf S1, so this should be 0, and let's also create so S2, and let's create S3, which is gonna have string S3 equals this, and my string put row S3, and we're gonna put XD, and this should return 1. So expected output is 0 and 1. 0, 1, yeah. So equals works, and destroy is gonna basically just free memory, free string. Yeah. So when we're done, here we don't have to do this, but free memory. Let's check this out as 1. Let's actually debug S1. Free, no, destroy. My string, destroy. Yeah. expected. Everything works. Oh, it was quite a mental exercise for me, and you kind of understand why Rust programming language exists, right? Like safe programming is actually a pretty important problem. So yeah, maybe there are bugs. We're making this just to have a basic understanding of how our basic tools work, really. And yeah, I'm gonna put this code on GitHub. Thanks for watching. Actually, I have a lot of interesting ideas for future projects. I'm thinking about making something in JavaScript, but not web, but rather just basically not a kind of web development, but I want to do something with 3D graphics, and I actually have an idea of the project for the project. I think it's gonna be a challenge, but that's probably a good thing. Many more ideas, like maybe some networking, basic networking in Python or Java, something like that. Maybe a chat, create a chat application, I don't know. But yeah, probably the next project is gonna be all about 3D graphics in JavaScript, and I actually have never done anything in JavaScript. Like I've done some web development stuff in JavaScript, but nothing like just a good old program, and especially not using graphics libraries or anything like that. So this should be interesting. Yeah, thanks for watching, and bye bye.